So Rashmi and Dimpy both are a test architect. Rashmi is actually associated with Happiest Minds, and she is having a profound experience in testing a big data applications with the help of a test automation framework. She has an hands-on experience on performance testing, web-based applications, and microservices. She is enthusiastic and always on her toes to keep herself updated with the latest technologies. And we have Dimpy. Dimpy is a test architect again with 16 plus years of experience and worked predominantly in web, API, mobile, and EWH testing area, and well versed with developing a test strategies to complex architectural problems, establishing and implementing automated strategies. So, and she is actually a profound speaker for ATA from a long term. She is being associated with Agile Testing Alliance as a speaker for various events, various conferences, along with Selenium and APM conferences as well. So, welcome back, Dimpy, again as a speaker. And now, this Rashmi and Dimpy would be speaking on follow a tweet on a big data pipeline testing. So, probably not taking much of her time, and I would actually hand over the session to Rashmi and Dimpy. So Rashmi and Dimpy, over to you.
Thank you, Jackie. I'm just sharing my. Can anyone confirm it's visible?
It's visible.
Thank you. Welcome all. Thanks for joining our session. So today we are going to talk about the topic, follow your tweet, which is nothing but a big data pipeline testing. Now let's see what is in there for agenda. First, we'll give a brief intro of what a big data pipeline is, followed by a use case, which is follow your tweet using Twitter, then a small demo. We have done all this, then we will be presenting a detailed test strategy, how to test a big data pipeline, which will be covered by Dimpy. Before getting started with what a big data pipeline is, let's understand what big data is. As the name suggests, big data means it's huge, big, high in volume. So how is it different from the traditional data that we always been using it? There are 3 V's which differentiates big data from the traditional one. That is volume, velocity, and variety. When I say volume, the amount of data that is being generated is very huge. Be it from your IoT-based applications, sensors, logs, social media, anything, the amount of data that is being generated today is very huge. Then comes velocity. We know the volume is very high, but at what speed are we generating this data? Just imagine yourself, you wake up in the morning, you take your phone, you see someone has posted something about their party last night and posted some pics. You go like it. Then you have something in your cart, you want to buy it. You buy there. Then you listen to music. You have to pay some bills. You do bills, then shopping. So a single person in his day-to-day life with a regular routine generates so much of data. So the velocity, the speed, with which the data is being generated is tremendous. There's a stats which says trillions of data is being generated, like trillion terabytes of data is being generated every day. Now we know volume is too much, velocity is very fast, then comes variety. When we say variety from how is it different from the traditional? In traditional, whatever data we know, it was like in a row versus column. It used to be stored in a table. A proper structure was there. So those are called structured data. Like your Excel sheet, your normal tables, all these are like, there's a proper structure defined to it. Then comes semi-structured. Here the structure is minimal, like you have your XMLs, your JSON, your Avro, all these fall under your semi-structure. Some schema is defined and accordingly your data is being presented. So they are called semi-structured data. The third one, which is unstructured data, it does not have any schema. Here, take in case of a log, a text that is being sent, your messages, your audio files, video files, all these will fall under unstructured data, which does not have any schema. With this high volume, with great speed and no structured data, processing is what matters a lot. So for this, big data has arisen. With this, the processing, how the traditional systems were not capable, and big data techniques have helped in processing the data. Now that we understood what big data is, let's see what a data pipeline means. As the name suggests, data pipeline, which is flow of data from one system to another. So from where we extract data, we call it as a source. And where we finally dump everything and use it, we call it as sink, destination, target, any of those names. But every data pipeline has a predefined set of steps or the process. First is the data ingestion layer. In this layer, we try to extract data from source systems. Then comes your processing. Here in data processing, you want to clean some data, do some aggregations, perform some basic name changes or column changes, anything that you want to perform. You do some basic processing. After processing your data, you want to store it. So you can store it in a normal RDBMS or in NoSQL database based on your use case. If you want to store where there is no structure and all, and NoSQL serves the purpose, then you can store it in the NoSQL databases. You have extracted, you have processed, you have stored, and the volume is very huge, but you want to make some sense out of it. We have done all this activity. So we need to visualize what our data is, what are the stats that we are going to extract from it. So for that, you apply some analytics, basic analytics or complex predictive analytics, any of those analytics, and build some dashboards, reports, or BI, any of those front. So that is the final data analytics or reports. Now we know what a data pipeline is, but there are flavors of data pipelines. So the basic ones are batch processing and stream processing. Again, the batch processing means we are dealing with batches. So like maybe every 6 hours, you want to extract some data from your source system and you want to do some processing, or every 12 hours or once a day. So that is called batches. It's like you're taking a chunk of data, playing around and storing it. Whereas the other one is stream processing. Everything goes through the same process itself, but the way we process is different. And when it comes to stream processing, it's live data. You ingest, you create an event, it gets flown down till your reports. That is near real time. That's how stream processing. It's like live data. We will be seeing more of stream processing in our use case as well. So with this, we know what a big data is, we know what a data pipeline is, the flavors of data pipeline. Now let's see our use case. When we started with this presentation, Olympics was in trend. So at that time, we considered this as one of our use case. Now consider there's a sporting company. They want to target their sports equipment or establish a factory in some specific country, but they are clueless like where they want to start off with. So maybe they in which geography sports is more active. There might be countries where sports is not that active when compared to some other. So they want to do some analytics on it, on the data. So in this use case, what we are trying to do is on Twitter during that trend, during that period. So we know number of hashtags will be generated. Anything related to sports, be it IPL, football, Olympics, sports, anything on sports, we try to extract the data from Twitter and put it into a streaming platform. Here we are using Kafka. Kafka is a message queue, but it's more of a streaming platform wherein any live data that can be passed through Kafka, which has topics, and it can be stored in respective topics. Later, somebody can consume that data from that topic. So here, then comes your processing. In processing, you can apply any of the big data techniques like Hadoop, MapReduce, you can apply. Then we have Apache Spark, Storm, Flink, all the latest techniques that is needed. So big data techniques can be applied here. Then you have extracted data, did some processing, now you want to store it. So these all are your consumers, which is consuming the data that is stored in your Kafka topics. And finally, we are dumping all the data that we have extracted, did some basic processing and storing it into our MongoDB. Now we have all the data that is needed, and we are going to build a small visualization which will help us analyze from where the tweets are coming, who are the active tweets, how many tweets per day we are generating, what is the sentiment of the tweet, are they speaking only negative, positive, how it is. I hope this is clear. This is our ingestion layer, this is our processing layer, this is our storage layer, and this is our reporting. So this is how a data pipeline is divided into. Now that we understood our use case, let's do a kind of a demo wherein we will be presenting. Now we have written a small piece of code wherein we have a producer. When I say producer, that is the one which is extracting data from Twitter and putting it into our Kafka topic. So let me, and if you see, we are tracking these kind of hashtags, anything related to sports, Olympics, IPL sports, any of those. And we are storing it into a topic called tweets. Now let me run my, before that, yeah, let me tell you, we need to install Zookeeper, Kafka, MongoDB, all that is pre-installed. I have turned on all my servers, like my Zookeeper is running, my Kafka is running, my MongoDB is running, all these are up and running. Now let's try to run our producer, which means it is trying to extract the data from, see, Twitter API is initialized and real-time feed, we are trying to extract it. Now the tweets are coming in and we are storing it into Kafka topics. Now that's done. Let's go to our MongoDB, wherein we want to consume whatever data we have received after and processed, and we want to store it into our MongoDB. Now you can see we are just printing a message saying that our records are being inserted into our MongoDB. Now let's go how our dashboard is. We have used basic Python libraries like Plotly and all, and built a dashboard using Dash. Now if you see, this is our live dashboard. Here you can see the most recent tweets. You can see it's the latest 11th, today's data is what we are trying to extract, and all related to sports. Then most active users tweeting by geo. Now if you see USA, the tweets are more from this geography. So any business decisions can be taken. I wouldn't say only this is the factor they'll consider, but in our use case, we are saying that based on which demography the people are active for sports, some decisions can be made accordingly. Now that is done, some aggregations also can be done. Maybe not only live data, today's data they want to do. They want to see over a period of time, in last 1 month, where from which geography the tweets are more or something. But here we're just calculating tweets per day. So every day these many tweets are being generated. And then a simple sentimental analysis has been done, how the tweets are. Around 85% of the tweets are neutral, and only some 2 to 3% is negative sentiment across it, and 13% are positive. So like Kafka is our ingestion layer. I mean, from Twitter, we are getting and ingesting it there. Then we processed it, we put it into our MongoDB, and we built a dashboard. So this is how a data pipeline is. Let's do a little more realistic. Now let me tweet something on IPL. Okay, ATA GTR. This is my Twitter, and I'm putting a hashtag as IPL, hashtag as Olympics. Dimpy, you can also tweet one so that we can show how the live data is being extracted. Yeah, so I tweeted it. I said. Thank you. So now let's go to our Kafka. Now let's search with Rashmi. You can see IPL ATA GTR. The record that was tweeted a second before is already being extracted, processed, and stored. This is how the data is being generated. We can also see Dimpy's data. She is also testing sports ATR live conference. So she's also tweeted. So we got it from a Twitter API. We have stored it in our Kafka topic, and we finished processing it. Now let's see. This is our MongoDB, and you can see whatever we tweeted is available in our database as well. Yeah, so Dimpy's tweet is also available. That fast is how big data pipelines work, and that's how everything is being done, developed, and processed. Let's see the dashboard once again. Okay, we haven't added any separate filters wherein it reads, we can filter our username, but I thought if we can quickly show here, maybe our tweets are already gone. So this is the overall view of how a big data pipeline works. And the tech stack that we have used is Twitter API, Kafka, MongoDB, Python, and for plotting, we have used Dash and Plotly. Fine, all this is done. This is our use case, but as a testers we need to know how do we test this. All this is the developers who develop and give you as a component for testing. That is what is more important now. With this use case as a background, Dimpy will be explaining in detail our testing strategy. Over to you, Dimpy.
My sharing visible?
Yeah.
Hi everyone, Dimpy here. Thanks Rashmi for explaining in detail about what is big data as well as what is big data pipeline and wonderful demo. Let me cover the testing aspects of the big data now. So when we test any traditional application, right? So we start with some set of data, right? And then we feed the data to the application and we see like, how the application is behaving or how the states are changing. And, we explore the application based on that. And then we report our findings basically. But in big data world, testing is little different, right? So because here we test data as a product. So it's not like an application. We test the entire data basically. Since Rashmi was explaining, right? So there are 4 stages, right? Ingestion, processing, storage, and reports, right? So in all these 4 stages, right, we have different types of testing which we can perform. Let me go through each and every testing type here. We start with the functional first. So in a data ingestion phase, basically, right, where we extract the data from different sources, we mainly do 2 types of validation here. One is the data integrity check and data quality check. So what is data integrity check is all about is like we compare the data between source and a destination here. So the example which Rashmi was talking about, right? So the Twitter data. So we can actually compare the number of tweets. Maybe we can take a date range and we can compare how many number of tweets are there in that particular date range and in the source as well as in our Kafka topics basically. So that will be our first data integrity check. So once maybe that is verified, then we'll proceed for more detailed checks like data quality checks. So data quality has actually different dimensions like common ones like completeness, uniqueness, validity, consistency, accuracy, right? Compliance requirements. Even we check referential integrity. Let me again give you one example here. Suppose that Twitter example itself, right? So we really don't want to see any duplicate records in our in our system. So we consider duplicate records as invalid records. So that will be a valid test case for us. Similarly, like completeness, right? So how will make sure our records are complete? Again, that will depend on the business scenario. In our scenario, is like we are mainly focusing on number of tweets for a specific geolocation, right? And suppose we are getting some records where geolocation itself is not there, or we are seeing so many nulls basically, right? So we'll not consider those records basically as a complete record, or even consistency, right? So data should be proper, right? It should not be invalid. No, suppose we are looking for a data from a valid range basically, right? And we are getting some very old data, so that may not be of any use for our reporting purpose, right? So those kind of different data quality checks we generally perform here. Proceeding to the next area is data processing phase, where we actually verify the business rules basically. So as Rashmi was explaining, right? So in the processing phase, we do mainly the cleansing part, right? We clean the data, we apply the business rules so that actually when we save or we store the data, we can actually retrieve the data for our reporting purpose. So here all the business rules, like you may have different business rules for different data sets. For example, like Twitter may have some for Twitter we have set some business rules. Maybe we have another social media platform like Meta, we have another set of business rules. And sometimes even business rules client comes from the client, right? Some clients may not need all the metrics basically, right? So we can divide metrics based on the client requirement, right? So all those and maybe there will be some common business rules. All the business rules we need to verify here. So next phase is the data storage phase, where exactly we'll be storing the data in persistence storage, like in our example MongoDB, right? So yeah, so once the data is stored, right, so data should be available to be consumed by the upcoming or the next upstream applications, right? So data should be available always. If there is any retention policy, then we have to check those retention policies. Then we also check, like if there is any read write timeouts are happening, it is taking more time in writing into the storage. So those kind of checks we can do very well from the logs, right? The another important thing here is the query performance. So basically, data storage is the main place from where the reporting components will be performing various queries, and those queries will be having a lot of joins, right? Nested joins, then aggregation stuff, right? So the query performance matter a lot here. So we can use maybe performance profilers and all to check the query performance and optimize those queries. The last stage is the final reports verification. So we'll be having real-time dashboard where we can see our metrics, measures and metrics. There might be charts, drill downs, as you have seen the simple plot, right, which Rashmi was demoing. There itself we have seen charts and plots. So all those things we'll be verifying. But again, one important thing here, right? So we are not going do any UI check here. We are verifying the data. So that is the differentiator here. Then even report export facilities, right? So you may give different reports in different formats. User can export it into maybe CSVs, PDF or any other format, right? So those all kind of report verification stuff we'll be doing. Basically we'll be doing the data validation here for all the reports. So once we are good with all our functional check, right? So next let's move to the next area, like security testing. Yes, security testing is important here. So I'll give you again one example, right? So since Rashmi was showing, like my username and Rashmi's username was actually shown in the Kafka topic as well as in the MongoDB, but that is our personal data, right? So since for the demo purpose we have not masked it, but in real applications you should not see those kind of information in the DB and as well as in the report also, because all those are confidential information, right? So we should not see those things at all. And then the regular role-based authentication and authorization, since we'll be having a lot of reports, different customers, so all those things should be in place. The security measures should be in place. Going to the next, next thing, that is scalability. Okay, so scalability here, if you see big data application, right, so the infrastructure is very much important here. So the example Rashmi showed is again a simple one. She has created one Kafka broker and one Mongo node, right? So for this simple example, maybe that is sufficient. But in a real situation, right, so that kind of infrastructure may not scale basically, right? So today you are actually extracting data from one source, in our case Twitter. Tomorrow you may add new sources to the system, right? You may add new social media platforms to the system. So our infrastructure should be able to auto scale basically, right, based on the size of the data set, maybe number of data set, the frequency of updates. So all those things we need to consider when we do the scalability testing, and we can we should do a benchmarking basically. So next is the performance. Again, yeah, performance is also very much important here, because it's all about the infrastructure, right? So big data is all about the infrastructure. So as we know, all these 4 stages, so all these 4 stages, there are different performance measurements we can actually take. For example, in a data ingestion, the rate of collection of data is very important, right? So if you see social media, right, so the time when the users will be active, maybe beginning of the day or end of the day, right? So that time the performance may go down, right? So if we consider those kind of scenarios in our performance testing strategy, it will definitely help. Then in the processing phase, the data transfer rate we should consider. Then in the data persistence phase, the data insertion rate or the query performance is very much important, right? We can use profilers and all, as I was telling while explaining the functional area. And even the reporting phase, we need to check the download speed of the reports. And suppose it is a simple report, it may not take much time, but if you are downloading a monthly report, yearly report, right, with lot of data, it may take time. So if we consider those scenarios in for our performance testing, yeah, so it will help basically. Another area is performance of our the algorithms used for reporting purpose. We may use some machine learning algorithms, right? So suppose we want to see the performance of two algorithms and take a call like which one to select. So in that case also we can benchmark it and see the results basically. Moving forward to the other side of the mind map, you can see there are some new terminologies which are actually we are using in the big data world. So first one is the retention policy basically. So what is retention policy? Like how long you want to keep the data in our system. See, we are consuming data with a very high speed, right? So and if we need to store all the data for forever, right? So it is very it won't be cost effective basically, right? So you have to pay for it. Now based on our business need, we can define our retention policy like okay, we want to retain data only for 1 year or 2 year, after that we want to archive it basically. Or maybe suppose different clients have a different need, like maybe client one says like, okay, I want data only for 6 months. Maybe client two says, okay, I want data only for 1 year, right? So those kind of use cases we generally check while doing retention policy testing. All these business use cases and retention timelines basically, and we do a lot of regression test here. Next area is reprocessing and backfilling. Let me give you an example here. Okay, suppose the Twitter case itself, you have seen, right? For a particular day, or for a particular month, there is no data. Right, suddenly you have seen in your report there is no data available for that time period, right? So what we are going to do, we may need to do a root cause analysis for that, and maybe we found out like data is corrupted at the source itself. So whatever data has been pulled is not propagated to our reports basically. Or there might be a situation like data transfer itself has been failed. Source data was correct, but the data transfer script got failed. So there might be multiple reasons for that, and in that case we actually need to do a backfilling of that particular time period of data, rerun the pipeline and make sure like everything is again coming back to normal. So when we see in this case, right, in big data we see different partitions basically. Data you might be reading data from different partitions basically. So if suppose it might be a reason also, like you are reading data from a wrong partition and you are seeing those discrepancies, right? So you need to make sure, right, okay, suppose you need to read data from the month partition, but you are reading data from day partition and there was a huge difference you are seeing. Or maybe hour and minute, right? So you need data for minute partition and you are reading from hour partition. So in that case probably you have to truncate or drop the partition, create the partitions again, and then re-pull the data, rerun the pipeline and make sure everything works fine. So reprocessing again, suppose there are CR or defects exist in the system, then after those are fixed, then we need to make sure, right, the pipeline executes properly, and business logic should be verified, what is after reprocessing it done, and then we do regression testing here to make sure like there is no impact basically. Next is
Dimpy, sorry to interrupt. We just have now a couple of minutes to go because we guys are running out of time. So if you can,
sorry, I will be done in maybe 2 minutes.
yeah, that's fine. Okay, thank
Okay,
you.
yeah. So next is the monitoring and alerting. So monitoring and alerting is important because we are basically monitoring the infrastructure. We can add like data integrity monitors, then system, source system monitors, then performance monitors here, and based on the alerts, we can alert the needed parties, basically sending SMS alerts and all this type of testing, right? We generally, if we need to do it manually, it will take a lot of time, basically, right? So we mainly prefer to do it in an automated fashion, like we create data generator or data loader, which can actually load data from the production system to the testing systems. Then we can create API clients and database connectors, and then integrate everything into the CI/CD so that we can get a timely based feedback. And yeah, Rashmi, you want to add something here? I'm done. Yeah.
I think you have pretty much covered it. Only thing I could say is the challenges of testing that we see is skill set. I mean, we need to have a thorough knowledge on sequels and all. A simple left join is replaced with a simple join, and the data is loaded with incorrectly. So, we don't have UI. People from Selenium background or where there are UIs, APIs, and all, playing around with data which is in completely black and white. You have to query the data, understand, explore the data, why this is coming null, why this is not coming null. All those is playing only with data, black and white, data exploration. But once you start liking playing with data, this is a great area to play around or test big data pipelines. That's it from my side.
Yeah, these are some references and information about our social media handles. Yeah, thanks a lot for listening.
Thank you.
Yeah, thank you so much, Rashmi, and thank you so much, Dimpy, for sharing a wonderful session on big data. This actually helped us out to give a brief idea about what big data is all about and how can we excel into that particular domain if you would like to, right? So anyone from the audience would love to explore big data, probably they can get in touch with you. I'm very sure that people would be having a lot of questions, but maybe because of the time we would not be able to cover a lot of questions, and we have the next sessions coming up in next 2 minutes. So probably the one who has the questions, I would request them to please reach out on their social media handles or probably over a LinkedIn with all your questions, right? And probably Dimpy and Rashmi would be able to help you out on that front. So thank you, Rashmi. Thank you, Dimpy, for a wonderful sessions. Probably on big data, this was actually helpful. Thanks a ton. So